Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lecture. Today's lecture will be looking at topical questions on mass spectrometry. Mass spectrometry is an analytical technique that is used to determine the relative atomic masses of atoms, isotopic elements, and relative atomic masses of elements and relative molecular mass of compounds. Now, the question before us is a typical examination questions. We just want to solve questions on mass spectrometry. So look at the question. The question before us is natural phosphorus consists of one isotope, phosphorus 31. Chlorine exists naturally as two isotopes, chlorine 35 and chlorine 37, in the relative abundance ratio of 3:1. That is the molecular ion and the molecular ion plus 2 peak of chlorine. Now, chlorine atom. The mass spectrum of phosphorus trichloride contains several peaks corresponding to a number of molecular fragments. When a sample is analyzed using a mass spectrometry, when a sample is passed into a mass spectrometer, the first thing that takes place is ionization, where high energy electron gun is fired at the particle. Then what happens? It undergo ionization. It knocks off electron from the sample to produce what we call molecular ion. So if there's enough energy, the molecular ion undergo molecular fragmentation to produce positively charged particles, produce fragments which are particles. So what happened is that the sample analyzed here is phosphorus trichloride. Now suggest the isotopic composition of the fragments with the following mass number. So these are the mass number. I want to look at the isotopic composition once phosphorus trichloride undergo molecular fragmentation. So it's as simple as ABC. Now the sample analyzed is phosphorus trichloride, which is PCl3, and it consists of phosphorus 31, chlorine 35, and chlorine 37. So which are the two isotopes of chlorine? So the mass number 101. So if phosphorus trichloride undergo molecular fragmentation to give you a mass number of 101, so we're going to have phosphorus 31, chlorine 35, and chlorine 35 to give us 101. So if you add, you have 31 plus 35 plus 35 equal to 101. So these are the particles that we produce for 101, which is the molecular ion peak, I suggest. Then for 103, you have phosphorus 31, chlorine 35, and chlorine 37. So by the time you add 31 plus 35 plus 37, you have 103, which is the molecular ion plus 2. Then for 105, you have phosphorus 31, chlorine 37, and chlorine 37. So by the time you add, you have 31 plus 37 plus 37, which will number equal to 105. So it's as simple as ABC. So this one will be the molecular ion plus 4 peak. So it's as simple as ABC. So the sample just undergo molecular fragmentation. Then you can bring out the isotopic composition using what? Using from the mass number. So you have to deal with the elements that are involved. So now let's look at the second question. Predict the relative ratios of the peak heights of the 3 peaks corresponding to this fragment. Predict the relative ratios of the peak heights of the 3 peaks corresponding to this fragment. So they are referring to what? The molecular ion plus 2, molecular ion plus 2, and the molecular ion plus 4. Since it is chlorine, so the molecular ion will be 9:6 with the molecular ion plus 2 ratio 1, which is the molecular ion plus 4 peaks for a chlorine molecule. So it's as simple as ABC. So the relative ratios of the peak height is 9:6:1. Since as simple as ABC, just have to attempt as many questions as possible. I will continue to solve as many questions as possible. So let's move over to the next question. So this is another typical examination question before us. X is a product of the substitution reaction that occurs when chlorodifluoromethane reacts with bromine. There's only one natural occurring isotope of fluorine, which is fluorine 19. The mass spectrum of X shows molecular ion peak at mass to charge ratio 164, 166, and 168, which is the molecular ion plus 2, and the molecular ion plus 4, since we are dealing with the halogen molecules. Now what happened is that we are looking at chlorine 35, and chlorine 37, and we are looking at bromine 79 and bromine 81. So these are the molecular ion and the molecular ion plus 2 of chlorine, molecular ion, and molecular ion plus 2 for bromine. Now what happened? You have to complete table 3.3 to show all the molecular ions responsible for each peak. Now this is the molecular ion peak, and you have the compound CHClF2. So what happened? The formula of the molecular ions will be CF2, chlorine 35, then bromine 79, plus, since it has to do with ions, we'll be given 168. Then for the next one, 166, with the molecular ion with mass to charge ratio 166. That is the molecular ion plus 2. It will now be chlorine, carbon CF2, chlorine 37, and bromine 79, or CF2, chlorine 35, bromine 81, plus, so because they exist as molecular ions, so that is the molecular ion plus 2, which is 166. So any of these can work forward the molecular ion plus 2, which is 166. So it's as simple as A, B, C. So if you have to add the atomic mass of carbon, fluorine, then 35 chlorine, 79 bromine, you'll get 164. Then if you add the relative atomic mass of carbon, fluorine, then chlorine 37 and bromine 79, you get 166. Or if you add the relative atomic mass of carbon, fluorine, chlorine 35 and bromine 81, you get 166. So it's as simple as A, B, C. So this is another question before us on mass spectrometry. Typical examination questions. The techniques of mass spectrometry and NMR spectroscopy are useful in determining the structures of organic compounds. The three peaks of highest mass in the mass spectrum of organic compound L correspond to masses of 140, 143, and 144. The ratio of the highest of the molecular ion and the molecular ion plus 1 peaks is 43.3 ratio 3.35, and the ratio of heights of the M and the M plus 2 peaks is 43.3 ratio 14.4.1. So use the data to calculate the number of carbon atoms present in L. So it's an indication that since you are giving the molecular ion plus 1 peak, it's an indication that what the organic compound contain the carbon-13 isotope. The organic compounds contain the carbon-13 isotope. There's an isotope of carbon-13 in the organic compound. So what you have to do now is to calculate the number of carbon atoms. Since the expression of carbon-13, so number of carbon atom, the number of carbon atom N is equal to 100 divided by 1.1 multiplied by the abundance of the molecular ion plus 1 peak divided by the abundance of the molecular ion plus 1. Sorry, but divided by the abundance of the molecular ion. So 100 over 1.1 times the abundance of the molecular ion plus 1 divided by the abundance of the molecular ion, which will now be equal to 100 divided by 1.1 multiplied by the abundance of the molecular ion plus 1 peak is 3.35. Then the molecular ion peak is 43.3. So if you have to use your calculator, 100 times 3.35 divided by 1.1 times 43.3. So you have what? 7. So if I have to use my calculator, get 7, approximately 7. So the number of carbon atom N is equal to what? 7. Now the next question is, explain what element is indicated by the M plus 2 peak. So if you look at the M and the M plus 2 peak, if you look at the M and the what? M plus 2 peak, the M peak is 43.3 and the M plus 2 peak is 14.1. So mathematically, the M plus 2 peak is equal to 1/3 of the molecular ion peak. So which is 43.3 ratio 14.1, which will now be equal to what? 3:1. Therefore, the element is a halogen, which is chlorine atom. So the element indicated by the M plus 2 peak is equal to chlorine. So it's chlorine atom. So it is what? Chlorine atom. As you can see, it's as simple as A, B, C, because the relative height of the molecular ion and the molecular ion plus 2 peak is 3:1, which is 43.3 ratio 14.1 is 3:1. So it's as simple as A, B, C. So this is another question before us. The mass spectrum of compound X, C5H10O2 is recorded. The peak heights of the molecular ion and the molecular ion plus 1 peaks are 22.65 and 1.25 respectively. Use the data to show that there are 5 carbon atoms present in one molecule of X. So what they are trying to ask you is for you to calculate the number of carbon atoms. Since there is carbon-13 isotope, present carbon-13 isotopes, you have to calculate the number of carbon atoms. You are given the abundance of the molecular ion plus 1 and the abundance of the molecular ion. So what happens? You use your formula. Number of carbon atoms will be equal to what? 100 divided by what? 1.1 times abundance of the molecular ion plus 1 peak divided by abundance of the molecular ion peak. So what you have is what? 100 multiplied by abundance of the molecular ion plus 1 peak is 1.25. This over 1.1 divided by the abundance of the molecular ion peak, which is 22.65. So if I'm to use my calculator, 100 times 1.25 divided by 1.1 times 22.65. So you get 5.02, which is approximately 5. So N is equal to what? 5. So there are 5 carbon atoms present in one molecule of X. Now the next question is, the mass spectrum has a peak at mass to charge ratio 57. That means X has undergone molecular fragmentation to produce ions. So you have to complete the equation to show the fragmentation of X to produce this peak. So we'll have 57. So the mass spectrum has a peak at 57. So if you undergo molecular fragmentation, so the complete the equation to show the fragmentation of X to produce this peak, the peak at what? 57. So we'll have carbon, hydrogen, and oxygen. So 57. So we'll have what? 5 carbon atoms. So I think this one should be C3. 3 times 12, which is 36. Then oxygen. If we add one atom of oxygen, that is 36 plus 16. 6 of 12, write down 2 and carry 1. 3 plus 1, 4 plus 1, 4, have 52. So we need 5 atoms of hydrogen. So it will be C3, H5O plus. So what happened is that what? The mass spectrum that has a peak at mass to charge ratio 57. So the peak at that point, the mass to charge ratio, the particle with the mass to charge ratio 57 is equal to what? C3H5O plus. So we'll put C3H5, 3 atoms of hydrogen, 3 atoms of carbon, 5 atoms of hydrogen, and 1 atom of what? Oxygen plus. Then the next fragment, the next particle that will be left is we have 5 carbon atoms, so 3 has gone, so it will be C2. We have 10 carbon atoms, 5 have gone, we have H5. Then we have 2 oxygen atoms, so 1 have gone, we have, so this is it. So this is the complete equation, C3 H5O plus and C2 H5O. So it's as simple as what? A, B, C. So you just need to understand the concept of the operation of the mass spectrometer and also the molecular fragmentation that takes place and the general operation in the mass spectrometer during, analytical technique using the mass spectrometer. So this is another typical examination question before us. Topical questions on mass spectrometry. Now the question before us, compound F contains the elements carbon, hydrogen, and oxygen only. All carbon bonds in F are single bonds. The structure of F was analyzed by mass spectrometry and infrared and NMR spectroscopy. The mass spectrum shows that the mass to charge value for the molecular ion peak is 90. The molecular ion peak is equivalent to the molar mass. Now the ratio of the heights of the M and the M plus 1 peaks is 22.1, ratio 0.7. Use the ratio of the heights of the molecular ion, that is M, and the M plus 1 peaks, molecular ion plus 1, to calculate the number of carbon atoms in a molecule of F. So the first thing we do, we'll use the formula. We'll have to calculate the number of carbon atom. So the number of carbon atom N, number of carbon atom is equal to 100 divided by 1.1 times the abundance of the molecular ion plus 1 divided by what? Abundance of the molecular ion. So what happened is that what? It will now be equal to 100 divided by 1.1 times 0.7 divided by 22.1. So we have 100 times 0.7 is equal to, we have 70, then you have 1.1 times 22.1, which will now be equal to 24.31. So N, which is the number of carbon atoms, will be equal to what? 70 divided by 24.31, not 23.31, 24.31. So it will not be, something, use my calculating, 70 divided by 24.31, which will be equal to what? 2.87, with approximately 3. So N, which is the number of carbon atoms, is equal to what? 3. Now the next question is, suggest the molecular formula of F. Suggest the molecular formula of F. It contains carbon, hydrogen, and oxygen. So carbon is already 3. So we have 3 atoms of carbon, then plus hydrogen plus oxygen will be equal to 90, which is the molecular ion peak, which is the molar mass of the molecular ion peak is equivalent to the molar mass. So carbon is 12, so 3 times 12 is 36, plus hydrogen plus oxygen will be equal to 90. So hydrogen plus oxygen will be equal to what? 90 minus 36. So I'm to use my calculator now. 90 minus 36 will be equal to 54. Which is equal to what? 54. So for hydrogen and oxygen, the total mass is 54. So we are to share 54 between oxygen and hydrogen. Hydrogen have a relative atomic mass of 1, while oxygen have relative atomic mass 16. So what we're going to do is that we're going to share 54 between hydrogen and oxygen. So the easiest way to do it is to assign the value to the atom that have the highest relative atomic mass, which is oxygen. Then what is left will be for hydrogen. So oxygen is 16. 16 times 2 is 32. Let's say we are using 2 atoms of oxygen. 16 times 2 is 32. So 54 minus 32. 54 minus 32. We still have 22. So we can still pick up 1 oxygen. So we are taking 3 atoms of oxygen. 3 times 16 is 48. 54 minus 48. 54 minus 48 will be equal to 6. So that means we can take 3 atoms of oxygen. We can assign 3 atoms to oxygen and the remaining 6 atoms to hydrogen. So the molecular formula will be was C3 H6O3. So this is the molecular formula. So it's as simple as ABC. All you need to do is to attempt as many questions as possible. And it's very simple. So that's just it. So before us is another question that has to do with mass spectrometry. Topical questions on mass spectrometry. So we're looking at different questions. So this is a typical examination question. Now this question is about compound T, which is CXHYOZ. Part of the mass spectrum of T is shown. The peak heights of the M, which is the molecular ion, and the M plus 1, which is the molecular ion plus 1 peaks, are 33.9 and 3.4 respectively. Now you are given the mass spectrum of compound T, which is a graph of relative intensity against the mass to charge ratio. You are asked to calculate the number of carbon atoms present in T. So to calculate the number of carbon atoms, we use the formula N. We use the formula N is equal to 100 over 1.1 times the abundance of the molecular ion plus 1 peak, which is 3.4, divided by the abundance of the molecular ion peak, which is 33.9. So if I'm to use my calculator, say 100 times 3.4, this one will be 340, divided by 1.1 times 33.9, which will now be equal to 37.29. So 340 divided by 37.29 will be equal to 9.11. So the number of carbon atom is equal to what? 9 approximately. So X is equal to what? 9. Calculate X, the number of carbon atoms present in T. Then the next question, you are asked to deduce the molecular formula of T. So we'll have C9, we'll have 9 atoms of carbon plus hydrogen plus oxygen will be equal to the relative molecular mass. Now the relative molecular mass has to do with the molecular ion peak. Now from the graph, we need to trace the molecular ion peak. The molecular ion peak is the peak that have the highest mass to charge value, which is 150. So if you look at the peak, the peak that have the highest mass to charge ratio, mass to charge value is what? The molecular ion peak, which is the molar mass, which is 150. So what we do, we say carbon is 12, which is 9 times 12 plus hydrogen plus oxygen is equal to 150. 9 times 12, I'm to use my calculator. 9 times 12 will be equal to 108. Plus hydrogen plus oxygen is equal to 150. So hydrogen plus oxygen will be equal to 150 minus 108, which will now be equal to 150 minus 108, which is 42. It's equal to 42. Therefore, hydrogen plus oxygen is equal to what? 42. So the mass of hydrogen plus oxygen is equal to 42. So we have to assign to oxygen first. Oxygen has an atomic mass of 16, while hydrogen atomic mass 1. So we need to assign to oxygen. Then the rest will be given to hydrogen with atomic mass 1. So if we pick we can pick 2 atoms of chlorine from this, and 2 atoms of oxygen. We can pick 2 atoms of oxygen, not chlorine, but 2 atoms of oxygen, which is 32. 16 times 2 is 32. So 42 minus 32. 42 minus 32 is equal to 10. So we have 10. We have 10 left. So the 10 will be given to what? Hydrogen. So we have 2 atoms of oxygen, which is 32, and 10 atoms of hydrogen. So therefore, the molecular formula of T will be C9H10O2. So that's the molecular formula of T, which is C9H10 then O2. Now the next question is, the mass spectrum has a peak at mass to charge ratio 119. Identify the fragment lost from T to produce this peak. So the molar mass is 150. So 150 minus 119 is equal to 31. So the mass spectrum has a peak at mass to charge ratio 119. So the fragment lost from T to produce this peak has what? The atomic mass, or the mass to charge ratio, is 31. So we have to identify the fragment lost from T to produce this peak. Now if you look at the compound T, it contains carbon, hydrogen, and oxygen. So oxygen is 16. Oxygen has a relative atomic mass of 16. Hydrogen has a relative atomic mass of 1. And carbon have relative atomic mass of 12. So if we pick 1 atom of carbon, that is 12, plus, now oxygen is already 16. So let's pick 3 atoms of hydrogen. So altogether, carbon and hydrogen is 15. So we're left with 1 oxygen atom to make it 31. So with 1 oxygen atom. So the fragment lost from T to produce this peak is CH3O. CH3O, 1 atom of carbon, 3 atoms of hydrogen, and 1 atom of oxygen. 1 atom of carbon, 3 atoms of hydrogen, and 1 atom of oxygen. So it's as simple as A, B, C. So that is it. So this another typical examination question on mass spectrometry. Compound S contains atoms of carbon, hydrogen, and oxygen only. The mass spectrum of X is recorded. Information about the two peaks with mass to charge ratio greater than 100 is shown in figure 5.1. So we have a graph of the relative abundance against the mass to charge value, which is figure 6.1. The molecule of X contains 6 carbon atoms. Demonstrate that this is correct using the information from figure 5.1. Show your workings. So what happened is that to calculate it, number of carbon atom N is equal to 100 divided by 1.1 times abundance of the molecular ion plus 1 divided by abundance of what? The molecular ion peak. So if you look at what we have here, number of carbon atoms equal to 100 divided by 1.1. The abundance of the molecular ion peak is 6.5. So from the graph, you can see this is the molecular ion plus 1 peak. This is the molecular ion, and this is the molecular ion plus 1 peak. So the abundance is 6.5 divided by the abundance of the molecular ion peak, which is what? 100. Relative abundance of the molecular ion peak is 100 divided by 100. So if I'm to use my calculator, we'll have, so let me use my calculator. So it will now be 100 multiplied by 6.5. So you have 650 to be equal to 650 divided by 1.1 times 100 divided by 110. So 650 divided by 110, 650 divided by 110 will be equal to what? 5.9, which is approximately what? 6. So demonstrate that this is correct using the information from figure 6.1. So from the workings, it shows that what? It is correct. Then you're asked, suggest the molecular formula of X using information from figure 5.1. So what happened is that from the graph, we need to get the molecular ion peak, which is the molar mass. The mass to charge ratio of the molecular ion peak is the molar mass, and the molecular ion peak is the peak that have the highest mass to charge ratio. So the molecular ion peak, which is the molar mass, will equal to 102. So we have to suggest the molecular formula of X. So we have the number of carbon atoms. Carbon is 6 plus H plus oxygen will be equal to what? 102, which is the molar mass, relative molecular mass. So carbon is already 6 times 12, I think, which is 72. 12 times 6, 72, plus hydrogen plus oxygen is equal to 102. So hydrogen plus oxygen will be equal to 102 minus 72. So you have 102 minus 72, which is equal to what? 30. So hydrogen plus oxygen is equal to what? 30, the total mass. So we have to share it between hydrogen and oxygen. Then we have to assign to oxygen. Oxygen has the relative atomic mass of 15, while oxygen has a relative atomic mass of 16, not 15, 16. Hydrogen have relative atomic mass of 1. So 30 minus 16, so we have 14 left. So the molecular formula of X will now be C6H 14O. So the molecular formula is C6H14O. Then now suggest the molecular formula of the fragment at X at mass to charge ratio 31. So the mass to charge ratio is 31 and the compound contains carbon, hydrogen, and oxygen. So what happened is carbon is 12. So we take one atom of carbon, then 31 minus 12. So we'll be left with 19. So if we assign 16 to oxygen, so we'll be left with 3. So we'll have 3 atoms of hydrogen and 1 atom of oxygen. So it's as simple as A, B, C. So the molecular formula of the fragment of X at mass to charge ratio 31 is equal to CH3O. So it's as simple as ABC. All you need to do is just to attempt as many questions as possible. And feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Please don't forget to subscribe to my YouTube channel and reach out to me if you encounter any difficulty. Attempt as many questions as possible. So I wish you the best in your exams. Thank you very much. Mr. Joe, your chemistry teacher. Please subscribe to my YouTube channel, like, share, comment, and please feel free to reach out to me if you encounter any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you for listening.